Okay, well, hi Justin, how are you? Hope you're well.
Yeah, not too bad, thanks. Interesting
Looking
paper.
forward.
Interesting paper that you sent over.
Good. I'm glad you enjoyed it. I thought it was interesting. It struck my eye as something that would be worth talking about. So we're going to try to have a little discussion about how to improve an abstract for a scientific paper. Every scientific paper has some story to tell. The researchers were motivated by some background information. They did something, they found something, and that story should come across clearly in the abstract. But it can often take a lot of work to make that happen. So let's try to look at that in the context of this paper. So this is one I found in PRL, a big physics journal. Can extreme electromagnetic fields accelerate the alpha decay of nuclei? So this is something I've been interested in for a long time. The idea that you might be able to speed up radioactive decay and maybe get rid of contaminated nuclear waste by doing something to it, shining light on it. I guess I thought of this long ago in terms of stimulated emission of radiation with light waves. Could you do the same thing for nuclear energy levels? It's a very different kind of physics problem. But anyways, these people are talking about this issue. And so the abstract is okay, but there's a background story that doesn't really come through clearly, I think. So the story, in a nutshell, is some other papers have recently claimed that they've studied how strong light waves passing through a nuclear material can cause it to increase its rate of alpha decay and therefore turn into other isotopes that are perhaps less problematic. So these several papers have claimed this. They claim that it should be possible in the near future with lasers that are on the horizon. And then this paper is looking at that interesting claim, and they say, no, we don't believe it. Actually, we've done this analysis. It's an interesting set of claims, but we've done the analysis. We think they made a big mistake in applying a certain approximation. We don't believe those things are true. It's not going to be possible in the foreseeable future as far as we can tell.
First, let's give everyone a chance to read through this abstract and get their heads around it. Feel free to read it a couple of times and put this on pause if that helps.
Okay, so Justin, you and I had a good chat about this abstract. Then we went off separately and tried to do some work on improving it, and then we came back and had another discussion, and then a third discussion, and in the end we kind of agreed on quite a few specific points about how this could be improved to tell the story, bring out the story more clearly. So we kind of captured those in a few slides. And we can just go through those now in the next half hour or so. Okay, so as we get going, so I guess first of all we should think, what's the point of an abstract? What is it supposed to do? What is a good one? What's a bad one? I think you're well placed to take a stab at this because with your archive blog, you produce one article about a paper on the archive every week. And you look through, I think, hundreds, maybe thousands of abstracts.
Yeah, it's a big filtering task, and you've got to be able to extract the key information as quickly as possible. And one of the things that makes it easier is the structure of the abstract. If you understand the structure of the abstract, then you can pull out the salient information much more quickly, and easily. But if the abstract doesn't have that structure, it's much harder. You've got to wade through it. So structure is a really important part of abstract writing and writing in general. And I think abstract writing in particular is probably the most highly structured form of writing you come across, because in a good abstract, every sentence has a specific function. And not only do you need to meet that goal of achieving that function, but you've got to show the readers what that function is as well. And that is a really tricky task, because it's easy to screw up. It's easy for people to get lost in abstracts.
Yeah, I agree. So here's a little schematic diagram. You can imagine a bunch of text behind there. That's an abstract. And every good abstract has a number of sections that play specific roles. The reader comes to this abstract not knowing what to expect. They need a bit of background on what the problem is. Who cares about it? Why is it interesting? What's the specific problem that has motivated this work? Maybe there's been some big controversy in the area. Maybe there's been some recent discovery, and this work is following on, trying to tie up some details.
Yeah, there's
some issue that is.
That's a really important point there, because the problem statement is the thing that is most often missing from poor abstracts. It's the most common mistake that people make, which is to set out what they've done and their methods and their results, but not say why, what the problem is that they're resolving. And then your readers are just left with a puzzle. Why have they done this? And so the problem statement is very significant.
Without the problem statement, you're left wondering, out of all the things these people could have done, why did they choose to do this particular study? And so the problem statement always tells you about their motivation, why they even undertook this experiment in the first place, or set of calculations, whatever it is. So it is really crucial.
And it has important implications for the background as well, because you're not just giving the general background for this area of science, you're giving the background that sets up the problem. So having written the problem statement, or come to the problem statement, and you don't have to write all of these in a linear order. One of the ways, or one of the tricks of writing, is just to get things down and then re-examine and think, what's missing, put it back in. And the actual writing process can be quite non-linear when it comes to it, but obviously the reading process is linear. So what we get to after the problem statement is how we've solved this problem, what we've done. And that's what we do here, or our method sets out. And then you follow that with what you find, and you end up with the significance of it, what you conclude. So the structure looks simple, and in essence it is simple, but in practice it's hard to get this right.
Okay, so let's go back to our nuclear physics paper and see how we might go about making some changes to improving this abstract. So the things we mentioned were missing were, well, first of all, it was lots of background. It was only late in the abstract we heard about these other papers that had made certain claims. Nowhere in the abstract did you hear about this big idea that we might be able to use lasers, even in the near future, to decontaminate radioactive waste. That's a big part of the story. That's an interesting goal. Some people have claimed it's possible. That's the motivation for this work. And so that really should come into the beginning of the abstract, and yet it's nothing there. So there has to be a whole section right at the outset just giving more information so readers can know the background of the story. So I think that's the kind of first thing that comes across. And I don't think we're saying this is a terrible abstract. In the spectrum of abstracts one comes across in PRL, this is perfectly functional. It works. People can understand it and they decide whether they want to read the paper or not. But it could be that a lot of readers don't really appreciate the background to this and flip past it because they don't see that this is a paper on a really interesting set of claims with potentially big implications. That's not made very clear in the paper, and it could be much better. So after our discussions, we each made a first effort, and out of that we kind of put things together, and we got this collection of some ideas. And we had, I think, 5 points going through the paper, trying to make a first draft of a better abstract that tells the full story. So the first thing, and we've used the same color codings as in the the block abstract we showed before. First of all, there needs to be more background, as I just mentioned. We hear nothing about this story about speeding up alpha decay of radioactive nuclei. We didn't really, or just obliquely heard this idea that some papers had claimed some interesting things about this. So we could, at the outset, just start with 2 sentences. In principle, extreme electromagnetic field alter the alpha decay rate of radioactive nuclei, raising interest in high-power lasers for the possible decontamination of radioactive waste. Recent studies have suggested that this could be possible in the near future. So that's really the background, and it tells you a bit of the motivation for why these 2 authors decided to sit down and start doing some calculations. The second part of the motivation, and this is really the statement of the problem, is that those earlier claims are controversial, and yet the controversy is unresolved. No one knows whether those claims are legitimate, illegitimate. It's just a mystery hanging over the field. And so that's a problem.
I think that's a really important statement right there. It sets up everything. It's a kind of climactic. Da, da, da.
Yeah, exactly.
So what comes next? Set up the problem?
Yeah, so you think, oh, no, it's controversial. No one knows the outcome of this. It hangs in the balance. And immediately, one can go on to tell the reader what these people are bringing to the table. What do they bring that's new? They say, here we do something that addresses that problem. We examine the prospects for controlling the alpha decay of nuclei with electromagnetic fields of extreme intensities, possibly in future lasers. And then some more detail on how they go about this. We rely on analytic arguments based on the Wenzel-Kramers-Briouin approximation and numerical calculation. So that's a famous approximation in quantum theory. It's not solving the full Schrodinger equation for this problem of the alpha particle getting out of the potential well. It kind of solves the problem in 2 different places and then patches it together in a semi-classical way. But it's a well-known approximation, widely used. So they say that's what we're going to use. So specialists would like to know, how did they go about doing their analysis? So they get that in there with a little bit of detail.
And there's a couple of other points that I think are important here, which are the words, here we examine. So one of the things that you've got to make clear to the reader is that we've moved from, say, talking about the background and the problem to our results and to our method. And the question is, how do they know that they're reading about the method? And the answer is that you have to tell them. And the way you tell them is by saying, here we examine, here we study, here we measure, whatever it is you've done, you say, we did it. And then the readers automatically know they're reading the method. And so that is a really powerful tool in abstract writing. Here we examine, and then you talk a little bit more about the method. We rely on these arguments. So we know that they've done it, and we know that it's part of their method. And that these signpost phrases, and we'll talk about them more later on, play a really important role in abstract writing.
Very much so. And I think, Justin, you've said this many times, you shouldn't let the reader think what they want to think. You should grab hold of them and lead them through the article and make them think exactly what you want them to be thinking at any particular time. And those trigger words and particular expressions are very useful ways to make that happen. So moving on, the next thing is the results. So what did they find? Well, as a first stab, we came up with this. We compare our predictions, and this is following along from the abstract as it originally was. We had lots of material at the beginning, and then the final 3 sections are closer to what the abstract originally had. So we compare our predictions with the optimistic findings of other recent publications and trace the origin of these results to the misuse of a standard approximation. And then finally, they give a 1-sentence statement of what they found. We demonstrate that no experimentally detectable modification of the decay rate can be observed with any current laser, nor is this likely in the foreseeable future. So the final 3 bits are fairly close to what the abstract as it originally was. The first 2 added a lot more background information, so the reader gets that motivating story of the interesting claims that have been made. Maybe we can wipe out nuclear waste with light, and then, well, maybe we can't, because this paper is correcting the field on that account. So if you put those things together that we just had there, this is what we get, and it's better. So if you read this, you do get the full story in a better picture. It's more enjoyable to read. You get the full weight of the argument. However, we have a problem. So, of course, in doing this, you get more words. 152 words now. We need to get back to 114, so it's around 40 words we need to lose. But this is typical. I mean, I don't know about you, Justin, but when I write something, the first goal is to get everything in there you need to get in there. And then later on, you can try to compact it, make the writing more efficient, get rid of little things that are repetitious or are unnecessary, and eventually you can get down a lot further than you think.
Yeah, that's right. I mean, the first drafts are just full of gibberish, additional thoughts that you haven't quite thought through properly, that don't need to be there, and it's only through the second and third and fourth edits that you begin to realise, why on earth did I write that? That wasn't what I mean at all. I've got to take that out. And you need to be ruthless with your own writing to make it as good as it can be, so that you end up concentrating all your best ideas in what you've written and taking out all the stupid things you write along the way. I mean, that's a really important point that you've talked about many times, Mark.
Yeah, it's very much an iterative procedure. So in the next few slides, we captured a few of the key elements we noticed while we were doing our editing. And some of them we thought about again. When we thought we were finished, we came back to it in discussion. We thought, wait a minute, we can still do more. And that's the thing with editing. You can always do more. But here's the key things we thought at the outset. So we have this sentence: in principle, extreme electromagnetic fields can alter the decay rate of nuclei, raising interest in high-power lasers for the possible decontamination of radioactive waste. And the next sentence says, recent studies have suggested that laser properties achievable could make this feasible. They're not identically repeating each other, but they're very much on similar wavelength, that we're talking about lasers, radioactive waste, near future, and these two things are a little bit repetitive, and we thought they could be replaced with a slightly simpler sentence or construction. So I think what we came up with was we stopped the first sentence with a full stop and introduced a new sentence, which was on this basis: recent theoretical studies have argued that high-power lasers may soon be strong enough to be useful in the decontamination of radioactive waste. I don't think that saves a lot of words, but I think it saves several, and I think also it does seem to be a bit clearer. Then moving on, we noticed something else, and this is a very minor point, but again, we needed to lose 40 words. So if we can lose 4, that's a tenth of the way there. And so this sentence says, yet, however, these claims remain controversial and their validity uncertain. We felt that we don't really need that statement, and their validity uncertain. I think I wrote that originally when we were rewriting the first draft of the abstract. Why I put that in there, I don't know, but it was a bit repetitious. If the claims are controversial, that means the validity is probably uncertain. And so that's really just a clear repetition. We can drop that latter part of the paragraph or sentence, so we save 4 words.
Yeah, I think that's a clear example of the kind of editing that you need to do yourself. You've got to be ruthless. And you think to yourself, it's only 4 words, but it's a significant percentage of that sentence. Cut it, it's better, it's clearer, it's more emphatic. And you just have to cut those kinds of repetitious phrases.
Yeah, it's eliminating the waste material that the reader no longer has to trudge through to get the picture. So beyond that, moving on, so we get to the here we examine sentence. So we've lost a few words so far. Here we examine the prospects for controlling the alpha decay of nuclei with electromagnetic fields of extreme intensities envisaged with multi-petawatt and exawatt laser facilities. This idea that we might be able to do this is already contained up in this section. So we don't really need to repeat that we're going to examine this issue, this claim, again, because we know what the claim is. So it'd be better to just jump right down, saying, here we examine, and just refer to it as this issue, and then go straight into what the methods that are used. So we could say, here we examine this issue by using analytic arguments based on thesis approximation and numerical calculations. So this is all a bit of repetition. It gets in the way for the reader. In fact, it'd be easier for them to just hear, they've just heard what the issue is, and those claims are controversial. We can just go straight to, here we examine this issue using analytic arguments based on the WKB approximation and other calculations. So right there, I think we probably saved 12 to 15 words right in that one little thing. And this is what often happens in abstract editing. You change a few things and shake it out, and suddenly this becomes clear how something else can be changed that simplifies the discussion, and you save a lot in an unexpected way. And then moving on to the next one, we compare our predictions with the optimistic findings of other recent publications and trace the origin of these results to the misuse of a standard approximation. So again, this is a somewhat weak statement. I mean, you read an abstract and you hear, we're going to compare our predictions. You don't know, well, did they find anything interesting? When they compared the predictions, what did they find? So better than just saying we compared the predictions is saying what you found about those predictions. So state the results more clearly, more emphatically. Don't leave it as a mystery to the reader. And this even can, in fact, save a few words. So a simpler way is to say we find a much weaker effect than other studies and trace this to their misuse of a standard approximation.
Yeah,
saved a few more words.
That's again a really important sentence. And this phrase "we find," again, that marks a transition from the methods to the results, and it makes it clear that we're reading the results. We find, and so I think that is a really important signpost phrase that sets up our expectations for that sentence.
And finally, final sentence, which is should be a conclusion. All right, so we found that it's a much weaker effect. So what's the implication? What's the conclusion that follows from that? Well, they say we demonstrate that no experimentally detectable modification of the decay rate can be observed in lasers that exist now, or for those likely in the future. So it's not really a conclusion. It's more like it sounds like there's another demonstration going on. So it ought to be, what can we conclude from this? What we just did in the previous sentence, which was we showed that the effect is much weaker than other people thought. So it ought to be a conclusion sentence following on from that, something like, we conclude that no experimentally detectable modification of the alpha decay rate is likely for any laser in the foreseeable future.
And again, that sets up our expectation for what we're reading. We're reading the conclusion. And how do we know we're reading the conclusion? Because it tells us, we conclude.
Right.
And, I think that's absolutely crucial, again.
So overall, this abstract is much, much better. It's clear, tells the story. And in fact, I think I did a word count on this one at one point, and it was 111 words. So we've beaten the goal of 114 words. So we're ready to do some minor touching up, because we noticed there's a few things we had introduced that aren't quite correct here. So oftentimes, after brutally hacking away, you need to step back a bit and think, okay, is everything we've done here okay, or have we changed the story a little bit? So we noticed a few things here. So extreme electromagnetic fields. That's not really what we mean. We don't mean fields of extreme frequency or of extremely strange waveforms or anything else. We mean one thing. The papers are all talking about electromagnetic fields of extreme intensity. And so that should be stated clearly and exactly, not in that vague way that we have it here. Can alter the alpha decay rate of radioactive nuclei. We're not really talking just about altering the decay rate. We're talking about speeding it up. So again, we can use a different verb to make the meaning more clear. And then down here in the end, we conclude that no experimentally detectable modification of the alpha decay rate is likely for any laser in the foreseeable future. It's really not maybe the best word. The foreseeable future, I mean, even science fiction is foreseeable future. I think we mean something more like, this is not plausible. Any laser that might be plausible in the future. So we can make a few changes there just to correct these minor inconsistencies. So electromagnetic fields of extreme intensity can speed up the alpha decay rate, And in the end, we suggested is likely for any plausible laser in the near future. So let's just iron out some technical issues. And then, again, going back to shortening things, the alpha decay rate, we're trying to speed up the decay rate. What's the difference between speeding up the decay rate and speeding up the decay? So the word rate is superfluous. We can get rid of that. On this basis, is that really necessary? I think we decided it wasn't. And also, we could replace on this basis with several. And that gives it, just emphasizes another little detail, which is that it's not just been one theoretical study that's claimed this interesting effect, but there have been several parallel studies by other groups. So we can replace that with several, and that brings that point across. And then, well, another down here is as yet. We can just get rid of that and start the sentence with however. And then this point is a little bit more tricky. I think I wondered about this because having read the paper, I realized that the theoretical studies, they were really focusing on judging the theoretical concept. If you apply a really high power electrical field to a nucleus, what's the effect of increasing the decay rate? That's what they're looking at, the physics of electric fields and decay rates. The high powered lasers stuff was a secondary thought. The implications of if this effect is really so strong, can we really actually maybe use high power lasers soon to affect this? So I think this should be focusing on what those recent theoretical studies focused on, which was the strength of the effect, the basic physics effect. So I think we came up with a way to get that into one sentence. Several recent theoretical studies have argued that the effect may be strong enough that high power lasers could soon be useful in the decontamination of radioactive waste. Just a little bit more honest, I think, in talking about what those theoretical studies really focused on, and then they made a suggestion that maybe high power lasers could reach those conditions. So with those changes, we're done. So we get to a final version that coincidentally has the same number of words as the original, but with a much improved structure. Of course, you can probably go spend another day and a half and get down to 105. I bet. I wouldn't be surprised. But at this point, it's pretty good. Much better than I think than the original was.
I think this is a good, well-structured abstract. Let's have a look at the structure.
Yeah, so we can put some colors onto this structure to bring out those various sections that we described before. And so here they are. There's the 5 sections. We have the background that talks about these recent papers, well, the basic effect, wondering if fields can speed up decay. The recent papers that claimed that it can much more effectively than other people thought before, and that near future lasers might be able to accomplish this. However, we hear the statement of the problem. These claims remain controversial. And then it's directly into what the authors are doing. Here we examine this issue and using particular methods. Their results, we find a much weaker effect than other studies, and they explain why those studies made a mistake, they believe. And finally, they conclude that no detectable modification of decay rates is likely in the near future. So that tells the kind of the whole story of the behind the paper. And there's some particular parts I think that maybe play a crucial role.
Yeah, these are the signpost phrases that we picked out that tell the reader that we're changing from one thing to another. They mark the transition from the background to the question. So the background is all of this thing, but however, there's a problem, and however tells people that you're going to come up with something different now. And it's a really important word. And then we say we examine, that tells the readers, that your method. We find, that's the result, and we conclude. That's the conclusion, and there's no question over what you're reading because it tells you. And these phrases, these signpost phrases and words form like the backbone of almost any abstract, and you can write them down before you write anything else and just add. So, however, this is the question. We examine, we measure, we study, whatever it is you do, and then fill in the blanks there. We find, we discover, we report, whatever it is that you find, and then we conclude, or our results suggest, or something along those lines. Those phrases can be written down before you write anything else, and they form, they set out the structure for you, but more importantly, for the reader, so they know what they're reading at any one time. Really important aspect of abstract writing.
So in the end, I think well, from our perspective, we did the work. We think it's an improvement. Other people can judge, but this is the basic idea of how to make the job for the readers as easy as possible, telling them the whole story of what was the motivation for doing this work, what were the interesting claims, what did you find, and what are the implications. And then the reader can get that quickly, and then hearing about that, they can decide whether they want to plow into the paper and read it or not.
And it doesn't mean that you have to use more words, as I hope we've demonstrated. So we hope this is useful, that you find some way to employ it in your work, and thanks for listening.
Yeah, enjoy the discussion, Justin. See you soon.